Welcome to our favorite YouTube channel DCT Electrical Knowledge. Today's goal is to learn special purpose machines, the hysteresis motor, a special kind of synchronous motor, the salient workhorse. Exam focus. Why is it perfectly quiet? How does it produce constant torque? AC motors are two types, three phase and single phase. Single phase motors are further classified as commutator motor, induction motor, and special purpose or synchronous motor. These special purpose motor are classified as stepper motor, reluctance motor, and hysteresis motor. We are here usually a 5 to 10 marks question. Get into the various exams. Let us see the picture. Stator, standard split phase, creates a rotating magnetic field. A rotor, the game changer. Notice anything missing? No teeth, no windings, no commutator. As a result, zero mechanical vibration, zero magnetic hump or humping, ultra quiet operation. The secret sauce means a special or unique. Rotor material made of hard magnetic material, generally chromium steel. It should be others hard material like as alnico, etc. But chromium steel is generally used as hard magnetic material. Non-magnetic supporting ever. Ever means tubular steel for structural stability inside aluminum or brass to reduce the weight. Weight, why hard steel? We want high retentivity and exceptionally wide hysteresis loop. Normal induction motor had this causes losses. Here, it is the whole point. What is hysteresis? Figure shows A hysteresis loop H, that is magnetizing force of stator, is represented along x-axis, and magnetic flux density of rotor, which is denoted by B, is represented along y-axis. Hard rotor has high retentivity. Hysteresis literally means lagging behind. The rotor magnetism is constantly fighting to catch up the stator field. Retentivity. Flux density stays high even when the magnetizing force is zero. Theoretically, an ideal hysteresis loop is always rectangular. Fatter loop is equal to more hysteresis loss is equal to more torque produced. Page 1. How it starts. Induction mode. Stator field NS. Stator creates a rotating magnetic field when the supply is given to the stator. The supply is also obviously single phase supply in case. Rotating magnetic flux sweeps across the stationary hard steel rotor. Thirdly, eddy currents are induced plus magnetic hysteresis creates a lag. That is, starting torque is equal to eddy current torque plus hysteresis torque. During acceleration, both eddy currents and hysteresis pull the rotor forward. Page 2. How it runs the magnetic lock. When supply is given to the stator, a rotating magnetic field is produced. The rotor is placed in the magnetic field. Due to rotating magnetic field, eddy current is produced in the rotor and subsequently produce magnetic field. That is, a rotor creates its own magnetic pole due to eddy current. Due to flowing eddy current, hysteresis loss also occurs. Due to hysteresis loss, a rotor flux phi r lagging behind the stator flux phi s, and as A result, an angle is generated between rotor flux and stator flux. This angle decides the torque, and the angle also decides the shape of the hysteresis loop. Torque is generated and motor is moving, that is rotating. Speed is increasing and stator starts to pull the rotor. As a result, synchronism or cogging occurs. That is, Ns is equal to Nr. So, relative speed is 0. S is equal to, that is, slip is equal to 0. As a result, induction effect is finished, and also eddy current is finished because eddy current produced due to induction. But how motor is running? Due to high retentivity of rotor, it behaves like a permanent magnet. As a result, stator pull rotor and runs as a synchronous motor. The lagging magnetic axis. Due to hysteresis loss, rotor magnetic flux phi r lagging behind stator magnetic flux phi s, and as a result, an angle alpha is generated between phi r and phi s. The angle alpha decides the torque, and the angle also decides the shape of the hysteresis loop. The torque is proportional to phi s into phi r into sine alpha. The special motor showdown. Hysteresis motor and a reluctance motor. Rotor. Hysteresis motor, rotor smooth, no teeth. Whereas reluctance motor, salient pole and or toothed. Noise. In case of hysteresis motor, silent and vibration free, and for reluctance motor, noisy. Magnetic humping is present there. Starting torque. In case of hysteresis motor, constant, handle high inertia, and in case of a reluctance motor, pulsating, low inertia only. A reluctance is cheaper, but hysteresis wins when silence and smooth acceleration are non-negotiable. Applications That is, where do we use it? Number one, sound production equipment needs exact constant speed so the pitch does not warp. Number two, timing devices. Synchronous speed ensure the clock keeps perfect time with the grid frequency. Number three, high fidelity audio. Zero gear teeth is equal to zero magnetic hump, ruining the audio recording. No more today. Next, we meet you in next videos. Please like, share, and subscribe my channel DCD Electrical Knowledge. Thank you.